So good morning, class. I hope you can hear me. So I believe you guys have already prepared for the for today's discussion. So today's discussion will be on the probabilities. Firstly, we will look at the probabilities, then uh, followed by the depreciation. Depreciation. So uh, today, let's start with foundational concepts and basic calculations here. So good morning. Uh, so we are going to dive into the subject that affects everything from games, from weather reports, to global finance, even AI, artificial intelligence. So artificial intelligence probability. Welcome, Diza and Ikmal. Are you guys ready to explore the mathematics of chance today?
Good morning, sir. Okay, I'm excited. Okay, it sounds interesting. I always hear people say that what are the odds? What are the odds? Now I know the math behind it.
That's a great observation. Most people encounter probability informally, but behind the scenes, it is a powerful tool used in decision making, forecasting. Sometimes you can see for insurance, they use probability. Engineering also they do use probability. Just name it. Let's start with by understanding what probability actually is. So, what is probability? Probability, in simple terms, we can put it like probability measures how likely an event is to happen or to occur. It helps us to deal with uncertainty. And you must understand that the value of probability is always false between the 0 to 1. Okay, the meaning to say the maximum number is 1. There's nothing more than one probability value. Meaning to say, for example, you can say 1.1, 1.2, 1.3. It's not possible in probability. Whereas you can see the lowest value of probability can be 0. And for your kind information, there's no negative value when it comes to probability. So 0 means the event is impossible. 1 means the event is totally possible, is certain, confirmed. It's confirmed 100%, 100%. So values between 0 to 1 represent a varying, changing degree of likelihood. We also express probabilities as percentages. So a probability of 0, for example, is a probability of 0.25 is the same as 25%.
So, sir, if someone says the probability of something is 0, like a penguin flying to class, that's impossible.
Exactly, Dila. Penguin can't fly, so the probability is 0. And probability of 1 would be something that guaranteed to happen. So, so for example, the sun rising in the east tomorrow, assuming no cosmic disaster, has probability of very close to 1. So, like the chance of rain tomorrow could be 0.3 or 30%. That means there's a 30% chance of rain and there's a 70% chance it won't rain. That's what we call complement of the event.
Oh, okay, sir. So the total should always add up to 100%.
Right. In any situation, if you list all possible outcomes, the sum of their probabilities must be equal to either 1 or 0. Either 1 or 100%. It means must be 1 or 100%. It's the same thing. So now let us just jump into a simple example, basic example on tossing a coin. Okay, let me just check on you whether your level of understanding after going through the sims. Yeah. So let's start. Simple. What happens when you toss a fair coin?
So you get either heads or tails. Head or tails.
Sorry.
You get either heads or tails.
Yes, Lisa, is it something? Head or tails? Yes, yes,
Mm.
yes, yes, correct. That means you get either head or tail. Correct. It's like a coin, we have head and tail. So when you flip a coin, then you can get head or tail. So we can calculate the probability. That means there's a 50-50 chance. So we can say the probability of heads is equals to 1 over 1 over 2. Okay, 1 over 2, which is 0.5%, which is 50%. The probability of tail is 1 over 2, 0.5 of 50% as well.
That makes sense, sir. So each side has the same chance.
I hope you getting it, Lisa.
Sir, can you hear me, sir? The line is not good. Hello, sir.
Okay, okay.
Are you getting me?
Can you hear me now?
Okay, I can hear you. Because it's quite lagging here.
Yeah. So
So
we
each
did
side
got
had the
the,
same
the
chance,
idea
50-50.
whether yes, yes. Correct. Correct. Exactly. Um, distribution. I hope you can hear me. The line is a bit breaky.
Yes, it's breaking,
Can
sir.
you hear me? Yeah. But can you hear me now?
Not that clear.
Okay. So 50-50 chance is what we call uniform probability distribution. Uniform probability distribution where all outcomes are equally likely. All outcomes are equally likely. So now rolling a die. Now let's roll a standard 6-sided dice. Dice, a dadu in Bahasa Melayu we call it dadu. So what are the possible outcomes?
Numbers from 1 to 6.
Good. If the die is fair, each number has the same chance. Okay, for example, probability of any specific number can be 1 over 6, which is about 0.167%. When you take 1 divided by 6, you can get 16.7% on 0.167%.
Okay, so what's the chance of getting an even number?
Okay, even numbers in a die, in a dadu, we have 2, 4, 6. The largest number is 6, the smallest number is 1. So therefore, you can see 2, 4, 6, 3 genap lah. So that's 3 favorable outcomes out of 6. So the probability of even number is 3 divided by, it's supposed to be divided by 3 over 6 is equal to 0.5, which is 50%. It's 50%. So now let us clarify some important terms that you normally see, especially the key definitions in probability, like an experiment in an action with uncertain result, like rolling a die. Okay, outcome, a result of an experiment, like getting number 4, and we have a sample space where all possible outcomes like 1, 2, 3, 4, 5, 6. And when we talk about the event, we have a set of outcomes we are interested in. A set of, like, for example, getting an even number or getting an odd number, and so on and so forth. Yeah,
So
do you have any questions?
Yeah, so the sample space for tossing a coin is heads and tails.
Exact, fantastic answer. Okay, now let's try one more. Give me another example.
So what about flipping 2 coins?
Excellent question. Excellent. Let's list all possible outcomes. So when we toss, when we flip 2 coins or toss 2 coins, we can get we list out all possible outcomes. So we have two coins. Okay. So first coin, second coin. So when we flip 2 coins at a time, we can get either both hit and hit, or we can get H and T.
Tail.
Okay, that could be one combination. The first coin is H, second coin also can be H. That first coin can be H, second coin can be T. The third coin, maybe the chances are like other possible outcome could be the first coin can be T, the second coin can be H, or both the coin first and second can get both T tails. So that means we can list out all possible outcomes which can be say like HH, HT, and TH and TT. Okay, so means there are four. The sample space has four outcomes, we can say. All right. So now let me just question you. What's the probability of getting exactly one hit by tossing two coins?
There will be a head tail, and tail head will be 2 out of 4, means 2 over 4 is 0.5.
Fantastic. Fantastic answer. Correct answer. You're getting things right. So now let us remove a little more challenging area where thinking critically about the likelihood, the chances. Likelihood in this case, we're talking about chances. Now that you have seen examples, let's think critically. Okay. So what's more likely? Okay. What's more likely? Rolling a number greater than 4 or rolling a number less than 4. Which one?
Okay, greater than 4 will be 5 and 6, will be 2 outcomes. Lesser than 4 is 1, 2, 3, means that 3 outcomes. So less than 4 is more likely, sir.
Great reasoning. Fantastic. This shows how probability helps us compare and make decisions in our daily lives. We can apply this in our daily lives. So now let's look at a mini exercise. So let's do a few quick ones. So you both of you try to answer. Okay, the first question I'll be throwing. Let's see who can answer. What is the probability of getting a hit when tossing a coin?
Is 0.5 equals to 50%.
Fantastic. That's right. So let me just throw another question. What is the probability of rolling number 1, number 2, or number 3?
There will be 3 outcomes out of 6. Means that 3 over 6 will be 0.5.
Very good. That's right. So let's go to the next question. Like, what's the probability of rolling a number greater than 6?
That's not possible, sir. It's 0.
Correct. In a dice, we do not have the highest number is 6. So 0 out of 6 we will be getting 0. So what's the probability of getting heads or tails?
That's 100% because it must be one or the other. So it's become 1.
Fantastic. So now you're doing so well. So always remember that probability doesn't predict exact outcome. It helps us to estimate, approximate how likely, possibly. Probability means possibilities. In one word, that's how we explain. So even if something has 90% chance, it still cannot happen. Yeah.
So like when I studied hard and still didn't win the quiz competition, maybe a 10% chance came true. At least.
Exactly. That's life. And probability helps us understand and manage those uncertainties.
So this is really more useful than I thought, sir. I'm starting to notice probability in so many things now.
That's the mindset of a mathematician. Excellent start. We will explore how to calculate these probabilities more than one event, like tossing 2 dice or drawing cards. Ready for it?
Yes, sir.
Yeah. Now we understand. Now that we understand what probability means, now let's talk about how to calculate it. Okay. So there's a simple formula we use. For example, probability of anything, probability of any event. So we just generally put the probability of event equals to number of favorable outcomes divided by the total number of possible outcomes. So probably you would have seen this formula in the sim and also in the PPTs.
So if I know what
so,
I want
yeah.
and how many total options there are, I can calculate the probability. Is it, sir?
Can you repeat if you don't mind? Sorry, I can't get it.
So if I know what I want and how many total options there are, I can calculate the probability. Is it?
Exactly. Let's apply this formula to some real life examples. Let us look at the point tossing. Point toss. Okay, now let me just check with you. What is the probability of getting hits when tossing a fair coin?
Only two possible outcomes, sir. It's either heads or tails. Since there's one favorable outcome, so heads we get. So means that heads is 1/2 is 0.5. It means 50%.
Very good, very good, very good. So now, Rizal, what would be the probability of not getting hits?
It would be the tails, so it's the same. Tails 1/2 is 50% also.
Right. So this is also shows the complement rule. Yeah. So which we can say that probability of not A, or we can say A prime. Sometimes we can say A prime. So one minusing out the probability of A. One is the total. One is the total. So one minus the probability of A. So you'll be getting the not A. You're getting the probability of not A other than A. So example, let us look at rolling a dice. Now imagine I roll a fair six-sided dice. So what will be the probability of rolling a 4?
There are 6 outcomes, 1 to 6. So only one is 4. So 1/6 is 0.1. The one that you said is 0. 1/6 is 0.167. It's equals to 16.7%. Sir, are you there?
Excellent.
Your line is my line, sir.
Yeah, I'm here. Okay. Can you hear me, Lisa?
Yes.
Yeah, I can hear you. Yeah, so you said 0.167, that's 1/6, 16.7%. That's like that. Excellent. Now let's increase the challenge a bit. Yeah? Now let us move into the maybe we can try to go into the rolling an even number, an even number. So what's the probability of rolling an even number? These are
even numbers on dice are 2, 4, 6 will be 3 outcomes. So means that 3/6 will be 0.5. 3/6 is 1/2 will be 0.5.
perfect. Perfect answer. Now you can find this. What's the probability of rolling a number greater than number 4?
Greater than number 4, it will be 5 and 6. So it will be 2/6. Sorry, it's 2/6 will be it equals to 1/3. 1/3 and will be 33.33%.
So about 33.3%, but 33%. Okay, so this is like greater than 4. Okay, that means greater than 4 is only about 33.33%, 1/3.
Yeah.
That means the remaining about I think 4/6 greater
70%.
So nicely done, nicely done. Yeah. So you have any questions so far?
What if the dice was not fair, sir? Like it's weighted or
Good question. In that case, we would use experimental probability or maybe weighted probability, where you can see the outcomes are not equally likely. But for now, we are working on the theoretical probability, assuming the fairness. Yeah. Any
so
questions?
this formula only works when all outcomes are equally likely?
Precisely. Okay. If outcomes are not equally likely, we need more data or additional rules.
Mm.
So now let us go into a practice round, maybe a mini practice round, maybe. Let's do. I'll give the event. Okay, you calculate the probability. Yeah. Okay.
Okay.
So I wanted to find out the probability of tails tossing a coin.
It's 1/2.
Rolling a die, probability of getting 2 or 3. Rolling a dice, getting probability 2 or 3.
Good. Is 2/6 is 1/3.
Yes, 1/3, correct. Yeah, 2 or 3. Two outcomes, because it's two outcomes. Very good. So what about rolling a die, finding the probability of getting number of lesser than 5?
Lesser than 5, it will be 1, 2, 3, 4. So 4/6 will be 2/3.
You get to if
2/3.
5 less than 5, you get 1, 2, 3, 4, 5. Oh, sorry, 1, 2, 3, 4. 4/6. So correct. So what about rolling a die? Probability of odd number. I want you to find rolling a dice, getting an odd number.
Odd number on the dice will be 1, 3, and 5. Will be 3/6, and then we calculate it as 0.5.
Very good.
50%.
Very good. So you're getting about 1, 3, 5. These are the 1, 3, 5 are the only odd numbers. Yes, correct. So three outcomes. Three outcomes divided by the total number of outcomes. This is what we call favorable outcomes. Only 3 odd numbers divided by all outcomes. So we're getting about 3/6, 0.5. Correct. So now let me just give you another one. Tossing a coin twice and getting hits both times.
So the
You
first,
can take your time. You can take your time.
tossing a coin twice, 2 times, getting hit at both times.
Yeah.
Okay, so it would be the first hit will be 1/2, and the second hit will be 1/2. So 1/2 times 1/2 will be 1/4. 1/4, sir.
That's right. That's right. But half times half. 0.5 and 0.5 getting about 1/4. Okay, now let us move into bonus thinking challenge. Let's go beyond. Suppose, okay, now let me just read out a question for you here. Suppose we have a bag with 5 rates, okay, 5 rates and 3 blue balls, okay. If one ball is drawn randomly, what is the probability of drawing a red ball? Probability of getting a red ball. I repeat. Yeah, you can take down. I can repeat. 5 red balls, 3 blue balls. Okay, let's say we have a bag with 5 red balls and 3 blue balls. Let's say one ball has been drawn. So what is the probability of drawing a red ball?
Okay. Total 8 ball. So red is 5. So
yeah.
P red is 5/8. So probability of drawing a blue ball is 3/8.
That's good. That's fantastic. So you see, when we add them, okay, that means when we add them up, it's going to be 5/8 plus 3/8. So you'll be getting 8/8, which is equal to 1.
Mhm.
So, uh, 5/8 campur 3/8 is 8/8,
Mhm.
supposed to be equal to 1 property
One.
value. Okay.
Mhm.
So now let us just quickly wrap up and recap. Uh, so the formula is property of event. It's the shortest formula that you can say is a favorable outcomes divided by total outcome, or favorable outcomes divided by all outcomes. This formula works for the theoretical probability, and when all outcomes are equally likely. So do you have any question?
Yes, it's like how we can apply the same formula to do so many situations. It's like a
Yeah, yeah,
logical and just count
yeah.
and divide, right, sir?
It is, and that's the beauty of a simple formula. So now, shortly, we'll apply it to compound events, and we see what happens when we combine two or more action, like drawing two cards or rolling two dice.
Looking forward to it, sir.
So now, let us okay. So now let us just do a short discussion before our first break. We take a break shortly, maybe for 5 minutes before we digest. So let us just move into the listing sample spaces. So
Sir,
so now
your
let's
line is breaking, sir.
so all possible. So can you hear me?
Sir?
Yeah, can you hear me? Hello, Lisa, can you hear me?
Okay, now can.
Yeah, great. Great. So now we are moving into the listing sample spaces. Yeah? We're moving into listing sample spaces. No, now if we try to understand it, sample space means all possible outcomes. Okay, all possible outcomes. So if tossing a coin, if we are tossing a coin, so the sample space will be either head or tail. Okay. Uh, so rolling a die. So the all possible outcomes or the sample space will be 1, 2, 3, 4, 5, 6. That's what we call all possible outcomes or the sample space. Tossing two coins, we can say that about head, okay, or head tail head and tail tail. Double tail, head and tail and head. These are the sample. This will be the sample space of all possible outcomes. So now, maybe to Ikmal and Lisa, what is the probability of getting exactly one hit when tossing two coins?
Is a HD and
Can you hear me?
TH.
Hello,
Can
Lisa?
hello, sir.
Yeah.
Can you hear me, sir? Sir?
Yeah. Yes, I
Okay,
can.
can.
I can.
Okay.
So excellent.
Yeah,
So yeah,
is HT and TH are the favorable outcomes. So means that 2/4 will be 0.5, sir.
excellent. So now let's look at a challenge, guys. What is the probability of getting an even number when rolling a die? Anyone?
Okay, the even numbers should be 2, 4, 6. That's the outcome. So 3/6 will be 1/2, and it will be 50%.
Perfect. So I think we can go for a short break, maybe about 5 minutes. How long do you need it?
Maybe 10 minutes, sir.
Okay. We take a 10 minutes break. Then we will continue with the subsequent session on the certainty, likely, uneven events and all that. Okay. All right.
Okay,
Let
sir.
us take a short break for
Okay,
10
thank
minutes.
you.
All right. Okay, shall we continue now?
Okay, yes, sir, can.
Okay, great. So now let us move into the another section, which is on the. Let me check with you on the impossible, certain, likely, and unlikely event. Yeah. So for kind information, I believe you have already gone through the scene. Probability also helps to describe how likely something is taking place. For example, probability zero, it means the impossible event. Okay, and certain event, the probability will be one. Likely event, very likely event, meaning to say very possible to take place, or likely event, we say that the probability is greater than 0.5. Means more than 50% of the chance for something to take place, a likely event, for some event to take place or something to happen. An unlikely event, if the probability is 0.5 or lesser than 50% chances for something to take place. So, for example, we can say that getting 10 from a six-sided die, okay, it is totally impossible. It is an impossible event where the probability is equal to zero. Whereas if you look at getting a number less than 7, if we say it like that, getting a number when we roll a die, okay, so getting a number less than 7 is very certain. It is very likely. So we can say it is the probability value is 1. Confirm this will take place. And another example, we can say like drawing a red card. Drawing a red card from a deck of from a full deck. So we can say very likely because we can get the deck of card is consists of half red and half black. So about, we can say 26 out of 52 cards. In a full deck of cards, we have what? 52 cards. Out of 52 cards, 26 is red. Half of it is red. 26 red and 26 black. Yeah. So it is it is likely, chances are greater. So,
So the
any
language, so the language of probability helps us describe chances better, sir.
yeah, you are right. You are right. So now let's go deeper. Let's talk about the compound events. So compound events means events combine more than one outcome. Now, it means combining more than one outcome. For example, and probability of rate and probability of a number cut, for example, or it means either or both. Let me just give you an example so that you have a better understanding. For example, tossing one coin and rolling one die. So now the question statement, let me just give you a question statement. What is the probability of getting hits and a 5? Can somebody try?
So coin will be 1/2.
Yeah.
Then the dice will be 1/6.
Correct.
So 1/2 times 1/6 will be 1/12.
Yeah.
One
Can you give in the decimal?
decimal is 1/12 will be 0.0833.
Yeah. Fantastic. That means you can see A and D, the key point, the key term A and the end. End means multiply probabilities of independent events. It means independent events. Yeah. So now let me just give you an example. If let's say drawing a red card or a king, okay, so the probability of red card is, we know already, which is 26/52, half, 1/2. And getting a king card. So how many kings we have? We must understand that. We have face cards. We have 3 face cards, Jack, Queen, King. Okay, and we have 4 different shapes. Yes. 4 different spades. We have clubs, and then we have this diamonds and hearts.
Diamonds.
Yeah, fantastic. So king card will be four out of 52. Four kings, yeah. 4 out of 52, and we want to see the or and here in this case rate intersection king. For example, we have four kings. Out of four kings, how many of the kings are red in color?
Only
We
two.
have two reds, yeah,
Mhm.
two blacks, isn't it? So
Mhm.
2/52. Okay, 2/52. Yeah,
So sir, we subtract the overlap to avoid double counting.
exactly. Fantastic answer. You are right. So now we got it very fast, and now we will move into the real life context here, and also we try to look at a little bit of the tree diagram, and we also look at the games of chance. Games of chance. And so now probability, real life examples. When we talk about probability application of probability in the real life examples, maybe like weather. We can also talk about the weather condition. 30% of chances of rain today, or maybe 30% chances of rain for the entire week, or maybe for the entire month or year also we can say. That is one example of its application. Other than that, in medicine, in the field of medicine, you can see side effect happens in 2% of the users. Taking this medicine, normally about 2%. Now, sometimes doctors may say, but taking Panadol, 2% of the people that taking Panadols can see the side effect. About 98% of them, they do not see any side effect. So these are some examples of its application in the real life scenarios. And also you can see in businesses also, 10% chance of stock to fall, the stock price to fall. Yeah. So I hope you're getting it. Yeah?
So it's used in decisions at all of the time, sir.
Yes, yes, yes. Even life insurance uses it. Yeah. Life insurance. Insurance has been heavily using probabilities. So now we are moving into let's go into the tree diagram. So tree diagram, you must understand, basically the tree diagram help people to visualize, for visualization, we use that, and help to visualize complex probabilities. So now let us try to apply a tree diagram using using a coin, flipping a coin example. So let's say you flip a coin twice. You can draw the first branch and also the second branch. So first branch, we can come from a left, right, two branches. One is what you can see this diagram in the videos that I've attached, embedded in the scene, where the first branch can be either hitch, or tail. So from the hitch, that means first toe, first twist, first flipping, second flipping. First branch for first flipping, second branch for the second flipping. So in the first flipping, you get the chances can be either 50% hit or 50% tail. So from the first flipping, the second flipping continues from the first branch. Yeah? So from H, it can be another two branches can be hit or tail, hit or tail. Okay. So therefore, the outcome will be first H, second H, or first H, second T, or first T, second H, or first T, second T. That's how we can easily apply that's how we can easily list out all possible outcomes or the sample spaces. So outcomes can be HH or HT or TH or TT. Okay, so I'm getting, I hope you're getting the idea. So the probability of two hits will be 1/4, 1/4 or 0.25.
So sir, it will help in organize sequences, sir.
Yeah, exactly. Yeah, right. So now let's play a game. We try to look at games on the expected value. So now let's say you flip a coin. Okay, if let's say if you get hit, we flip a coin. We bet. For example, we bet. If we get hits, you win 10 ringgit. If you get tails, you lose 5 ringgit. You lose 5 ringgit. So the expected value, can you calculate the expected value?
Mm-hmm.
Can you calculate the expected value?
So that means on average, I gain 2 ringgit 50 cents per play.
Fantastic. Fantastic. Because why? 50-50 chances. 0.5. So 0.5 from 5 ringgit is a 2.5. That's 50% chances because we have two outcomes only. In a coin, we only have a head or tail. Yeah? Two outcomes. So you are correct. So businesses normally use these to predict outcomes. Okay, so now let us wrap up. Let's wrap up on this probability. Final question, maybe. Probability. Now, let me just throw some questions to you. Probability of rolling two even numbers in a row.
Okay, two even numbers in a row. 3/6 times 3/6 will be 9/36 will be 1/4.
Yes, 25%, 0.25 or 25%. Fantastic answer. So now let me just give you another question, or maybe to you or Ikmal. Let's see who can answer. Drawing a black face card.
Black. Okay.
Okay. Face card can be either Jack, Queen, or King.
So black will be 6 black face cards over 52. So 6/52 will be 3/26.
Yeah. So you're getting a 3/26, and which you simplify it, divided by 2, 6 divided by 2, you get 3. 52 divided by 2, you get 36. Yeah. Okay. So probability of at least one. How if I ask you a question? Probability of at least one hit in two tosses of coin.
In two tosses, one hit, all the outcomes will be 4 because only TT is no hit. So will be 3/4.
Can you hear me?
Now I can hear you. Just now lagging.
Okay. Sorry.
Okay, all the outcomes is 4, sir, but only
Yeah.
one is only TT is no hit. So means that 3/4.
Very good answer. Very clear answer. Fantastic. Yeah. You did great. Okay. So let us explore the dependent probability, conditional event, and more on the real life cases for us to understand. Yeah.
Thank you, sir. I love how the logical this is, sir. It's so logic.
That's the goal. That's the goal. Probably helps you to think clearly. Okay, until keep questioning every time, everything and every time. So now I think we have to move into the mutually exclusive versus the non-mutually exclusive. Um, so we explore into simple, compound, and conditional probabilities. Conditional probabilities. Let us understand an important distinction between the mutually exclusive and also the non-mutually exclusive cases.
Sir, I've heard of mutually exclusive, but I'm not sure what it means, sir.
So let's define them clearly. Okay, mutually exclusive events means two events. We must have two events, and the two events are mutually exclusive means they cannot happen at the same time. They cannot happen at the same time. Meaning to say, if someone wants to give birth, the baby can be either a baby boy or a baby girl. That's just a normal example. Or let me just give you an example: rolling a die. Okay? So getting an event, let's say event A is getting a 2, event B getting a 5. So when we roll a die single time, these two events cannot happen together in a single roll, right?
All right. You can only get one number at a time.
Yeah. So they are mutually exclusive. They are mutually exclusive. So the formula for this will be probability A, U, the shape will be U. Okay, in sets, you see, U means ke semua. U means taking all of them. So A, U, B is equals to probability of A plus probability of B. Example problem. Let me just give you an example problem. What is the probability of rolling a number 2 or number 5? So now let me just give you an answer. So we see to get a probability of number 2 is 1 over 6. Okay. So P2 is 1 over 6 and P5 we can get about 1 over 6 as well, because we have only one outcome, a favorable outcome for 5 and one favorable outcome for 2. So you see, the shortcut is whenever you roll a die, you always 1 over 6. If the outcomes are within the range, within the sample space, it's going to be always 1 over 6. So now in this case, we are talking about the mutually exclusive case. So since two things cannot happen together, so it's 1 over 6 plus 1 over 6. We have to take the sum. 1 over 6 plus 1 over 6, we get about 2 over 6. Whereas if you look at the non-mutually exclusive case, two events are non-mutually exclusive, meaning to say they can happen at the same time. So two events can happen at the same time. So that means there can be an intersection point. Okay, so for example, you can see drawing a card from a deck. So let's say the first event or event A, we can put it drawing a red card. And event B, the second case may be like drawing a king card. Okay, getting a red card, getting a king card. So there are 6 red cards. Okay, we just discussed earlier, and 4 kings, 4 king cards in the deck of a card. So, but the 2 kings, one is heart shaped, the other one is diamond shaped, which are red. 2 reds and 2 blacks. So now the question here is, can A and B happen together? The answer is yes. Okay? That means these events are not mutually exclusive or not mutually exclusive case. Okay. So now let me just give you the formula. You can take it down. You can take it down, or you can refer to the SIM, self-instructional material that I've already shared with you. You can refer back to the SIM under the topic of probability. So we have the probability of A, U, B, probability P for probability, open bracket A, U, B is equals to probability of A plus probability of B minus probability of A intersection B. So the A intersection B is what we call as the common factor. It's a common factor, or we have to remove them from the calculation to avoid the double counting. Okay. So now let's calculate it. So when we take the probability of rate, the probability of rate is 26 over 52, 1 over 2. So basically, and probability of king is 4. We have 4 kings, 4 over 52. And probability rate intersection king will be 2 rates. So probability, in a single card, we can see rate and also king, rate and also king. So we have love shape or heart shape, which is rate and king. We have diamond shape, which is also rate and king. So we have 2. So what we do is we take the sum between the probability of rate, probability of king, and minus the probability of rate intersecting the king. So it's going to be 26 over 52 plus 4 over 52 minus 2 over 52. So we'll be getting about 28 over 52. All right. I hope you're getting it.
Yes.
Yeah. So now let us just move into, let me just test you whether you have really got it or not. Let me just throw you some interactive challenge maybe. So whether it is mutually exclusive or non-mutually exclusive. So let's see whether you can clearly see it or not. So now let's give you, let me just give you some scenarios. You tell me if events are mutually exclusive or not. So if I say selecting a student who is a male or a female.
It's mutually exclusive because it can be both.
Fantastic. Rolling a number. Okay, if I give you another one, rolling a number that is even or greater than 3, an even number or greater than 3.
It's not mutually exclusive because 4 and 6 are both even and greater than 3.
Fantastic answer. That means you see there are intersection, right? I mean, those numbers are greater than 3. also an even number like 4. So intersections are there. Okay, now let me just give you another example. Let's say tossing a coin and getting heads or tails.
It's mutually exclusive because it can be lent at both at the same time.
Yeah, getting heads or tails. Yeah, correct. It's a mutually exclusive, either head or tail. Cannot be two at a time. So now the fourth example will be scenario. Like you maybe say drawing a card. Drawing a card. From drawing a card, getting a spade or a face card.
Not mutually exclusive because some of spades are face cards.
Very good, very good. That means you are clear. That means very clear about the mutually exclusive and non-mutually exclusive examples and the concept. So now, why this matters is understanding whether events are mutually exclusive helps you to apply the correct formula. Okay, so which formula, whether you are to minus the intersection, the common factor or not. If you forget to subtract the overlap in the non-mutually exclusive events, your answer will be too high because you are
So it's a
double
common
counting.
mistake, right, sir?
So one of the most common, especially in exams. Now, let us just move into maybe let me just question you like a mini quiz where we do a rapid practice. Okay, let's see how fast either you or Ikmal can answer. So let's say rolling a die. Okay, event A is even number. You can even take it down. You can take it down. Maybe you can take 1 or 2 minutes to work it out. Then give me the answer or maybe to yourself. So rolling a die, event A, maybe I say even number. Event A is even number. And event B is number lesser than 4, smaller than 4. So are they mutually exclusive or not?
Number 2 is both even and less than 4.
Yes, there is no, it is not mutually exclusive. Fantastic. So another rapid question, maybe drawing a heart, drawing a heart or getting a queen.
It's not mutually exclusive because queen of heart in both.
Yes, you can see a single card with the queen with the heart queen.
Yes.
Very good. So tossing a coin twice. Okay, let me just throw another one. If we toss a coin 2 times, heads on the first or heads on second, is it mutually exclusive or non-mutually exclusive?
It's not mutually exclusive because you could get hits both times.
Correct. Yeah. Okay, now let me just be more practical, real life example. Selecting a weekday or weekend. Is it mutually exclusive or non-mutually exclusive?
I can say that it is mutually exclusive because a day can be both.
Yeah. It cannot be both. Either weekday or weekend. So
yes.
2 different things. So let's wrap up. Let's wrap up on this. So whether the question here is whether can both happen or not. 2 things can happen together or not. If cannot happen, it means mutually exclusive. It can happen means non-mutually exclusive. So we have 2 types of events here: mutually exclusive case and non-mutually exclusive case. If can happen together or both can happen, that means it's non-mutually exclusive. Therefore, the formula that you have to use is A. Probability of A or B is equal to probability of A plus probability of B minus probability of A and B. So we have to minus out the intersection here, the common factor. Whereas if you look at the formula for the mutually exclusive, is probability of A or B is equal to probability of A plus probability of B.
So, sir, this clears up a lot, sir. I used to forget. I always forget to subtract the intersection. Actually,
Excellent progress. This difference is the key mastery, is the key to mastering compound probability problems. Yeah. So now we shall move into depreciation. Okay, maybe as what I said, I want you to go through. We will take about 5 to 10 minutes, maximum about
okay.
10 minutes, for you to prepare for me to question you on the chapter depreciation. You go through, read through whatever exercises and notes that you have already studied earlier. So go through on that, prepared for the depreciation for a couple of minutes. Then we will discuss again. I would like to ask you some questions on the depreciation, discuss with you and Ikmal, both of you. So
Okay.
try to prepare a little bit, about 5 minutes. How long you need? 5 minutes or 10 minutes?
It would be nice if 10 minutes, sir.
Okay, take 10 minutes time and prepare nicely prepare on the depreciation so that you can answer me. Okay.
Okay. Thank you,
All
sir.
right. Thank you. Thank you. Please let me know once you're ready. Yeah.
Yes, sir.
So I hope you are ready and prepared with the depreciation. So
Yes.
let me just test a little bit on the depreciation with you. Then later I may brush up with you on the depreciation chapter. Maybe I will go through with you with the quick lecture, maybe rather than discussion, so
Mhm.
that you will have a better understanding on the depreciation. Uh, okay, now let us start the depreciation part. Introduction to depreciation, where we're going to look at the concept and its importance. So basically, today we are focusing on something uh, that does not just affect accountants and businesses, but actually it affects everyone who owns a car, who owns a phone, even a laptop. So today's topic is depreciation. Okay.
So, sir, this is so new, but I've heard them the term apa when people sell used item, is it for the depreciation?
Great observation. Yeah. Yeah. Uh, so second-hand websites mentioned also depreciation, right? Yeah. So depreciation is essentially the reduction in the value of an asset over time. It's the most important concept in both personal and business finance. Yeah. So now let us talk about why do depreciation. Why do assets depreciate? Uh, so why do things lose value? Anyone?
Because they get old.
Or because they are used
They
too
use
much.
too much. Okay, correct.
Correct. Okay, let me just share with you some few main reasons. For example, wear and tear. We can see machineries used daily wears out, and obsolescence. A new model makes the old one less desirable, or passage of time, where some assets lose value by aging. Or usage. The more of something is used, and the faster it loses value.
So, sir,
So
if I
yeah,
don't use my phone, is it loses value?
exactly that. That's called time-based depreciation. Okay, so now let us discuss what is depreciation. Sorry, why is depreciation important in business? So businesses use depreciation for a number of reasons, several reasons. Firstly, you can see to identify the book value of assets. So that will be the main reason. Secondly, we can see to spread the cost of an asset over its useful life. And also for tax deduction, tax calculation and tax deduction, and accurate profit calculation after tax profit calculations, and also to know when to replace the particular asset.
So, sir, it's not just about the market price, right? It affects how a company reports its performance.
Yeah, that's why it's part of every financial statement. Uh, so now let us just move into the methods, the common methods of calculating depreciation. Okay, so the common way or common method used to calculate the depreciation is you can start from straight line method. Straight line method. So straight line method is the simplest method of calculating the depreciation. Yeah. So now, how can we calculate? Is I think you have probably seen in the scene. Okay, so where you can get the annual depreciation calculated by taking the cost minus the residual value or receipt value. Okay,
So
so
what?
cost. Yeah,
So what is the residual value again?
a good question. Yeah, good question. Residual value is the estimated value of the asset at the end of its useful life, and it is also known as the scrap value, residual value and scrap value. Besi buruk. When you
Mm-hmm.
when you use a machine, then you want to throw it in the besi buruk, then you get some money, right? So that is
Mm-hmm.
the easiest way to remember to understand the
Mm-hmm.
residual value, or we can also say the scrap value. So now let me just give you an example for better understanding on the straight line method. So let's say a company buys a machine for 15,000 ringgit. A company buys a machine for 15,000 ringgit. Let's say the scrap value or the residual value is 3,000 ringgit lah, about 3,000 ringgit. Let's say it is after the useful life or after using for 6 years. Now let us calculate the depreciation. Who can do that? So you can say
It's
15,000. Let me just give you the answer.
15,000
Divide
uh
minus
minus
3,000
3,000.
divided
It
by 6.
it
Divided
will
by
be 12,000.
uh,
So we'll divide by 6 because this
yeah,
life years the life useful years is 6 years. So
uh,
will be 2,000 per year.
correct. How do you get the 2,000? 15,000 minus 3,000, you get what? Yes,
3,000.
12,000.
Yeah,
Divide by
divide by
6 years.
12,000 divided by 6 will be
Uh,
2,000.
yeah, you get that. 2,000 per year. Good. So the
So
machines,
after 3 years, the depreciation will be 6,000.
yes. So the book value becomes 15,000 minus the 6,000, you get about
9,000.
9,000. 9,000. Okay. So, so the good things about the straight line method, the benefits of the straight line method is one is it is easy to calculate, very easy, straightforward. Secondly, you can see it is equal expense every year. Okay, equal expense every year. But it is best for assets used consistently over time. Okay, like example, furniture, buildings. Yeah. So, do you
Sir,
have any question? Yeah.
yes, sir. What if an asset only lasts for 2.5 years?
Good thinking. In that case, we can divide depreciation across months also. Okay, businesses do that when they need more accurate reports. So now let us go into a little bit on the reducing balance method. The second type of method is the RBM. We call it as a RBM method, which is reducing balance method. Okay. So sometimes it is also known as the diminishing balance or declining balance method. In some textbooks, they used to say like that. So now, here the depreciation is actually the percentage of the asset's current book value, not the original cost, not the original cost. Now, let me just give you an example on the RBM, reducing or declining balance method. So let's say you can take it down. You can take it down and you can do the calculation one. Let me just do the calculation for you. Maybe you can also calculate with me together. So let's say a computer is 5,000. Let's say a 5,000, and we take the value of 20% of the depreciation per year. Okay, 5,000 computer. You paid for you bought a computer for 5,000, and the depreciation. Let's say the depreciation rate is about 20%. So now let us calculate the depreciation for 3 years using the declining balance method. So maybe you can say first year, 20% from 5,000. So if you calculate the 20% for 5,000, 0.2 times 5,000, you'll be getting about 4,000. Now, about
4,000.
1,000, 1,000. So you take the 5,000 minus the 1,000, you get 4,000. That is the book value. Understand? Can I?
Okay.
So if you go to the year 2, so the book value means the current value. Okay, that means after the year 1 to year 2. It's moving from year one. Year one is 5,000, but year two, after the depreciation of 1,000, now the book value means the current value, the year two value is the book value. The latest value of the particular machine will be 4,000. So 20% reduction from the 4,000, like your car insurance, every year be reducing, right?
Yes.
The same idea. So 20% from the 4,000. 4,000 you get about 0.2 times 4,000, you'll be getting about 800.
800
Yeah. So now you take the 4,000 for the book value, the current year book
minus
value
800.
yes, you'll be getting about the latest book value
3,200.
3,200. Fantastic. So now with that, so for the year three, when you go to year three, it's going to be another 20% from the 3,200.
1,200.
Yeah. So it's going to be about 20% from 3,000.
640.
But that's very fast. 640 is the depreciation value. And the book value will be 3,200 minus the
3,200 minus 640 will be 2,560.
fantastic. Fantastic. So any question, Lisa?
No.
Okay. So now we will move to the
Oh, sir,
summary.
sorry.
Yeah.
So
Yeah.
the depreciation amount decrease every year, is it?
Exactly. It's the grade for assets that lose value quickly at the beginning, like electronics or also cars or vehicles. Yeah. So now I think we shall go into a quick summary on what we have done. Straight line method, SLM, straight line method, and also the declining balance method or reducing balance method. Okay. Summary here. We look at the criteria. Okay. Criteria. We look at several criteria of these two different methodologies that we discussed. So you can see the depreciation amount used for the formula and also the residual value. Okay. So you see in the reducing balance method, there's no residual value. Okay, we are not talking about the scrap value or residual value. We're just looking at the percentages. But straight line method, we use the residual value. A formula will be the fixed amount for the straight line method. Whereas we look at the diminishing balance or reducing balance, the fixed percentage of the book value, 20%, 20%, 20%. And it is used for, normally the straight line method is used for the building furnitures, this kind of fixtures and furnitures, normally fixtures and furnitures. Whereas for the reducing balance method approach will be normally used for the cars, computers, kind of vehicles. That will be for the decreasing. So, and the depreciation amount will be same each year for the SLM, straight line method. That is what is criticized normally. Yeah? But for the cars and computers, it normally decreases over time. Percentage will decreases over time. So now with this, we will move into the real life application and also try to do some practice. So real life example, let's say, let's talk about selling a phone. Selling a phone, simple phone. These are how much did your phone cost last year?
It's 2,400, sir.
Wow. And how much could you sell it for today?
So it's maybe around 1,400.
So 2,004 to 1,004, that means it has depreciated around 1,000 in a year, in 1 year.
Yes.
We can say 1,000 over 2,4, let's say
Mm.
about 41.7% depreciation.
Yeah.
So this is similar to the reducing balance depreciation, a fast loss in the first year. Okay, so now let us look at another example, maybe phone, maybe car now. Let's say you buy a car for 60,000 and let's say it depreciates 15% per year. Okay, 15% per year. So can we do the calculation?
Yes. 60,000 minus 15% will be 9,000. So the value is 51,000.
Oh, that's for the first year.
That one is for the first year.
Yeah, for the first year. What about the second year? How is it for 2 years? As you calculate for the 2 years.
Okay,
So
second year will be 51,000 times 15% will be 7,650 minus 51,000 will be 43,350.
That's a big drop. Huh? That's why resale value is always lower. Okay, so now let us just go into a group challenge maybe.
Okay.
Let's see whether Iqmal is, you can participate through typing. Uh, Try this on your own. I'll guide you if needed. Okay, so let me just give you a problem, throw you a problem. You can take it down. You can take it down, do it slowly, and let me know. Uh, Take it down. Asset. Let's say there's an asset. I don't want to say car or what. Asset cost. Asset cost is equals to 25,000 ringgit. Take it down. Asset cost 25,000. Let's say I give you a residual value. Residual value is 5,000. 5,000. The moment you see the residual value, you understood it's a straight line method, like SLM. Straight line method. And let's say the useful life will be 4 years. Will be about four years. So now what you do, you use the straight line method, SLM, to calculate. I wanted to calculate two things. First, you calculate the annual depreciation. Second, you calculate the book value. Book value at the end of year 3.
So for the first one is annual depreciation. So depreciation will be 25,000 minus for 5,000 multiplied by 4 years will be 20,000. So 25,000 minus 20 divided by 4.
4 years. Yeah.
Yes, it's 4 years. Then it's 5,000 per year.
Per year.
So another one is so after 3 years, so the 5,000 times 3,000 is 15,000. So the 15,000 is depreciation. So the book value will be 25,000 minus 15,000. So the answer is 10,000.
Fantastic. Fantastic answer. Spot on. So now let us just wrap up and reflect on the concepts, on these two concepts, and also look at the real world scenarios or connections, the link of the real world. So why depreciation matters is because of number one, for the correct or accurate financial reporting. Companies they need to report they have to minus the depreciation value from the assets they have, especially the balance sheet. So next is for the proper asset-based valuation. We can do a valuation in three different ways. So especially it would be very useful for the asset-based proper asset valuation, for asset-based valuation, company valuation. And also it helps in the budgeting for replacement, the replacement value, valuation for the replacement value, and also helps in the taxation saving. So we can calculate the depreciation, so that helps with tax saving. So Lisa,
So it's not just a number, sir. It helps businesses plan and survive.
yeah, that's right. So you
So I
can
will use
probably
this if I want to open my own shop someday.
That's the goal. Understanding how math applies to life. Okay. So now let us just go through on some quick rapid fire kind of questions. So let's see whether both of you can participate. Okay. So these are or Iqmal, let's see what's depreciation.
The decrease in value of an asset over time.
Very good, very good. That's the fastest way. That's the simplest, the shortest definition that you can provide to somebody. And now, let me check on. Just give me two methods of calculating depreciation of the study.
It's a straight line and reducing balance.
It's RBM or SLM, straight line method or reducing balance method. Which method has the same amount every year?
It's a straight line.
Very good. Still method will have the same amount every year. And which method is better for electronics, vehicles and all that?
Is reducing balance.
Yeah. Yeah. Reducing balance will be better because in terms of its percentages. Yeah. So now let me just give you a case. Huh? If a laptop costs about, let's say, 4,000 ringgit, and let's say it depreciates about 20% per year, what's its value after 1 year?
So
Can you calculate?
4,000 minus 20%, it will be 3,200 for the
Yes,
first year.
that means 80, yeah, 80%. When you take the 80% from the 4,000, it will be about
4,000.
3,200.
Yes.
So I would like to give you the homework or project assignment for maybe you can try it at home. You don't need to submit to me on this, but you can just try it at home. You can keep it where you can even take it down, jot it down. Both of you can take it down for the next class or maybe later on. You can even post it in them in the Moodle. We can post them your answers in the Moodle. Okay, so maybe what you can do is you try to interview an activity kind of. You try to interview someone who owns a business or somebody who is managing assets. Ask them how they handle depreciation. Practically, how do you deal with the depreciation? Even yourself also you can. And what you do is prepare a one-page summary or maybe like a couple of paragraphs is enough with any numbers they give you. So try to estimate depreciation on item that they own or you own. Yeah. So will that be possible?
Yes, sir. Because I can ask my uncle who runs the cleaning service. He buys machine too. So that one will be
Oh,
depreciation on the machine.
excellent choices. So let's wrap up here. So now with the depreciation, I would like to quickly do another two methods with both of you. So I would like to go through the lecture quickly, the lecture on the depreciation. Uh, so far, what we have covered is we only covered the uh, two methods. Now, let me just go with you uh, with another two methods. Yeah? Maybe let me have both the slides and also the theme. Just give me a few minutes.
Okay.
We are not entirely done with the depreciation yet. Maybe we also will look at the depreciation in our next session. But what we do is we try to we just go through with you on the chapter 6. So I hope you can see my screen.
Okay, Ken.
Yeah. So I would like to run the slide. I mean, not the slide, but the scene. So we have discussed so far we have discussed the straight line method. A straight line method where basically calculates the annual depreciation. Okay. And also we jump to the declining balance method. In fact, we just looked at one type or one kind of the declining balance method. We have also calculated, discussed, I think we've calculated this. But in next class, I may discuss with both of you on the unit production method and also the sum of the years digit method. So now we just have discussed with you, both of you, on the depreciation formula where you can see where we look at the depreciation per year. This is the depreciation formula where cost of asset. So this is the initial cost. The initial cost. Initial cost of the machine purchase, which is the cost of the asset minus the salvage value, residual value. Or also known as scrap value. So residual value or scrap value, they are known as the salvage value, and also the number of years useful life, right? So now you can follow the steps as what we have discussed to find out. Step one is basically to find out the cost of the asset, of the fixed asset, and then after that we have to find out the expected or the estimated useful life of the asset. Right. So now next you can also do what you can subtract, minus out the cost, the salvage value from the cost and divide it by the useful year, the number of years, basically the number of useful life of the asset. Have to minus with this so that you can get the yearly, so that you can get the yearly. So here is an example that has been shown on the year of depreciation, and also you can see this one you can use Excel. It's how you can use Excel to calculate the depreciation. When it comes to large numbers or big numbers or many years, we can use the application of Microsoft Excel to calculate the straight line method here. So cost of boiler plant useful life is 10 years. So the salvage value is what, 50,000. This is about 1, 2, 3, 4, 5, 800,000 is the cost of the asset. The useful life is about 10 years, and the residual value is for 50,000, about 50,000. So you can use this formula here. Okay. So you can use the formula for B5 because it is in the cell B. All of them are cell B. So B, cell 5. Okay. So that will be the B5 here. B5. And you can the same cell, but the salvage value here, the residual value here, B7. So B5 you are instructing. So you have to type it equal to the Excel. Equal to, you want to calculate the depreciation per year formula. Just have to type equal to B5, open bracket, B5 minus the B7. You can say it is, you can even try this later when you have the time. You can just type it in Excel. Then you can do this exercise. So B5 minus B7 divided by B6. B6 is this one. So provided we are in the this is what we call rows from a left, right, rows. And these are the columns, top to bottom. These are the columns. COLUMN columns. So A, B, C, D, E, F, G until Z. These are the columns, and the rows will be running number 1, 2, 3, 4, 5, 6. So if they are in the column B, then you put B5 minus B7 divided by B6. So you can do the calculation here. It will give you the value there. As I can see that depreciation per year is about 75,000. So I can take a look at this. I can also try to do these activities over here. So I have given you a number of activities here, number of tasks for you to try out, for both of you to try out on task 1, task 2, task 3, and also task 4. Okay. So I hope you have done that. So now I would like to stress on the units production method. So you can watch a video. You can follow this instruction down here. You can watch a video, and you can see the formula of the units of production method. So step 1, what you have to do is you have to take the same idea of SLM, straight line method, where you can see the cost minus the salvage value divided by the total units of production. That is the step 1. The step 2, then what you do is you take the depreciation per unit. So you are calculating the depreciation per unit in step 1. So you're calculating the depreciation per unit in step 1. So once you're done with calculating the depreciation per unit, so what you do, you take the depreciation per unit, you times with the number of units produced. So for you to get the step 2 depreciation examples, expense, depreciation expense. So now let us look at this example here. A company purchases a machine for 50,000. The machine has estimated useful life of about 100,000 units. So this one is they give you in terms of the production units. So that's why we call it as a unit of production depreciation. Okay, and they provide a salvage value too, a residual value too. A declining balance method, and you recall what we have discussed earlier. The reducing balance method or declining balance method, there's nothing on the salvage value. It is all in the percentages. That is specifically for cars, vehicles, electronics kind of things. Okay, but here is we're talking about the units of productions. So for the first 2 years, machine produces the following units. Let's say the machine able to produce 15,000 units the first year. The second year is about 25,000 units. So we have to calculate the depreciation expense for each year using the units of production method. And also we have to find out the book value at the end of the year too. So for that, what we can do is first you apply this formula. You can get this formula from here. So see here. Can use that formula down here with the depreciation per unit, cost value minus the salvage value divided by the total number of units. So it's very simple math where you take the 50,000 minus the 5,000 divided by 100,000. So you'll be getting about 0.45 per unit. So what is this? This is actually the depreciation per unit. So depreciation per unit is 0.45 per unit. So after once you've calculated with this, so what you do, you take the first year depreciation, first year production rate, 15,000. For you to calculate the depreciation. So 0.45 times the 15,000, you're getting about the depreciation expense will be about 6,700 for the first year. The second year, you can see you take the 25,000 times the same depreciation per unit. So for 0.45, you'll be getting about 11,250. Okay. So finally, you can calculate the book value at the end of the year 2. So if you look at the book value at the end of the year 2 is a cost minus the accumulated depreciation. So your cost is about 50,000. From the question here, you can see the machine cost about 50,000 units will be the cost. So please give me a couple of minutes. Let me just finish it here. So cost is about 50,000, and you can see 50,000 minus the 6,750 plus the 11,250 that which you get it from here. So the 11,000 will be the cost of the depreciation expense. 6,750 is also depreciation expense. So take the cost of the value. Both years depreciation expense will be getting about 32,000. So 32,000. You have to repeat if it is for the end of the year 3. And so Riza, can you hear me? Are you there with me? Riza, can you hear me? Can you guys hear me? Yeah.
Okay,
So,
sir, can.
Yeah, great. Great. So you can also try to do the activities here. So factory machine depreciation, vehicle usage depreciation, equipment depreciation, and printing depreciation. So just give me about another 5 minutes for me to just show you the areas that you have to revise so that we can do our discussions on this area. So this is the first area. The second area, I want you both of you to look at the sum of the years method. Yeah, for next session. So next session, I'll be throwing so many questions to both of you. to test your level of understanding on these two areas. Yeah? So it's going to be intensive chats or rapid fire kind of questions. Yeah. So please try to do enough revisions, study and do enough practices. Do the practices for few times so that you won't get stuck. So far, there's no problem. Both of you, especially Lisa, you're progressing so well. And all the questions that I've thrown to you, you should be able to answer perfectly. So close to perfect, zero mistakes and errors. So likewise, if it's keep up your good work, I want you to keep the momentum. Do whatever you are doing. You're doing the right thing at the moment. So these are the two main areas that I want to show. And if you look at the section 1.3 here, so I just want you to look at the 1.2 and 1.3. So the formula for the 1.3 is just depreciation expense. Is equals to, for you to calculate, this is for the sum of the year's digit method of depreciation. So for this, you just have to get the remaining useful life divided by the sum of the year's digits times the depreciation balance. You have to watch a video. Please watch a video. There'll be a clear video on this. I'm not running the video, so I just want you to look at the example here. Give me a couple of minutes. Let me just finish with the examples. Then you can take it from here. So if you look at the example calculation over here, we have the asset cost about $10,000. And we have salvage value. Again, I repeat, the salvage value, we're talking about the residual value, we're talking about the scrap value. We have the salvage value about $1,000, an asset cost about $10,000. We have a useful life of 4 years. So we have to calculate the SYD. So again, going back to the earlier one, SLM, RBM, okay, unit production method, depreciation method, and also now we have the SYD. Okay, SYD. So step one. So what we do, we take the 4 years, number of 4 years times 4 plus 1 divided by 2. Okay, 4 plus 1 divided by 2, we get it for the SYD. Sum of the years digits, we get about 10. Then you calculate the annual depreciation calculation where remaining 4 years. So you can calculate the depreciation is 4 out of 10 times the difference between the cost of the asset and also the salvage value. So you're getting about 3,600. So year 2, remaining life of what? 3 years. Then year 3, remaining life of 2 years. Then year 1, remaining life of what? 1 year. So this will be a calculation. So how much is the depreciation? Yearly depreciation. Yeah. So I hope you can go through on this, and we shall discuss. Try to do all the self-check questions here. Try this self-check, and also finally the declining balance method. One area that I want to highlight is self-check. Okay, I want you guys to have enough self-check and do all the self-check, and also practice. Watch this video and more videos. You can watch more videos and also refer to the suggested reference books. So try to read and look at some examples from the reference books, so that there will be very good preparation for this topic. Yeah. So I think that's all for today. Do you have questions? No questions, then we can end for the session.
No questions, sir. Thank you so much,
No
sir.
questions. Thank you very much. Thank you very much for joining the sessions. We may end the session for today.
Okay, thank you. Bye.